Okay, so we're going to solve systems of equation using elimination now. Okay, just like with substitution, I've got the process written down that you would be following. So the first step is if you have fractions that are present in the system of equations, get rid of them first. Just like we did with the last example that we did with the substitution method. And you can get rid of your fractions by multiplying the equation by a common denominator. Second step is to choose which variable you wish to eliminate, x or y, and then what you're going to do is multiply one or both of the equations by a number so that the coefficients of the variable that you want to get rid of are equal. That may not make sense right now, but I think you'll make sense of it when we look at our first example here. Then we're going to subtract the two resulting equations, solve for the variable that's left over, and then of course we're going to have to solve for the other variable. And when it comes to solving for the other variable, I could substitute back into one of the initial equations, or I could just do the elimination process again, but when I'm at step 2, just choose to eliminate the other variable instead of the one that I eliminate in the first part. Okay, so let's look at the first example here. Okay, so I've got 3x minus 4y equals 7 and 5x minus 6y equals 8. So I don't see any fractions here, so I don't need to worry about getting rid of them. So now I'm going to choose which variable I want to eliminate. It doesn't really matter if I eliminate x or y. The process really is still going to be very similar. So I'm going to choose for now to eliminate x. Okay, so my goal then is to make new equations that really don't have any x term in them. So remember, step 2 now is to multiply these equations by some numbers that make these coefficients the same. So what I'm going to look for is a common multiple between 3 and 5. Well, what's a number that both 3 and 5 will go into? Well, 15, right? So to make these coefficients 15, I could multiply the first equation by 5 and the second equation by 3. Okay? So let's do that. Excuse me. So I take that first equation, multiply everything in there by 5. So this is going to be 5 times 3x, 5 times negative 4y, 5 times 7. Okay, so that of course gives me 15x minus 20y equals 35. Don't forget that you also need to multiply the 5 by the 7. It's a very common mistake to forget to multiply this number by the 5. I've seen plenty of people just carry the 7 down here, so be careful about that. Alright, so now what we're going to do is take the second equation and multiply it by 3. So there's the second equation multiplied by 3, so 3 times 5x, 3 times negative 6y, 3 times 8. Okay, multiplying everything by 3 gives you that there. Okay, so now what we've got are those two equations like that. Now, these are essentially the same system of equations, but you notice that my x coefficients here are the same. So what I can do, just like when I add, subtract, multiply, or divide terms, I can add, subtract, multiply, or divide equations. So in a case like this, if I'm trying to get rid of my x term here and I have the same coefficients here, well, really, if I take these two equations and I just do the 15x minus 15x, that gets rid of that x term. So that's why we subtract these equations. So what that's going to do is get rid of the x term. Then I would have negative 20 minus negative 18. So of course, subtracting a negative is the same as adding a positive. So negative 20 subtract negative 18 is the same as negative 20 plus 18. Okay, which of course gives me negative 2y. And then 35 minus 24 gives me 11. Of course, now, if I'm trying to solve for y, I need to get rid of the negative 2. So to get rid of the negative 2, I would divide by negative 2. What I do to one side of the equation, I need to do to the other side. So both sides divide by negative 2. This gives me y equals negative 11 over 2. Okay? At this point, I've got y, but I still need to find out what x is, right? Okay, so I could do this two ways. I could take a negative 11 over 2 and substitute it back into one of these equations for x, and then solve for y. However, it's a bit of an ugly number. So what I could do instead is to just do the elimination process again, but instead of eliminating x this time, I can eliminate y. So I take the same system, but now I'm going to eliminate y. Okay? So I want these coefficients to be the same. So I'm looking for multiples of 4 and 6. I could see that both of those go into 12, and to make these negative 12s, I would have to multiply this equation by 3 and the second equation by 2. Okay, so multiplying this equation by 3 gives me that. 3 times 3x, of course, is going to be 9x. 3 times negative 4y is going to be minus 12y. 3 times 7 is 21. Likewise, I multiply the other equation by 2. 2 times 5x is going to be 10x. 2 times negative 6y is going to be negative 12y. 2 times 8 is going to be 16. So here, what you notice is that my y coefficients are now exactly the same. So what I can do is I can take my two equations and subtract them to get rid of the y. So subtracting my x terms here, 9x minus 10x gives me negative 1x, or negative x. As we mentioned, negative 12y, subtract negative 12y. Well, subtracting a negative is the same as adding a positive, so negative 12y plus 12y gives me 0, so I'll just leave it blank. And then 21 minus 16 is 5. I need to find out what positive x is, so what I can do is I can imagine that this is a negative 1 coefficient in front of the x. So to get rid of that negative 1, I would just divide both sides by negative 1. Negative divided by a negative here gives me a positive x, and over here I've got 5 divided by negative 1, which gives me a negative 5. So at this point I've got x to be negative 11 over 2, and then y to be negative 5. Okay, so that's my answer for that one. Let's look at a second example. This one's a little bit uglier, but if you know the tricks to get rid of those fractions, it really just simplifies down to the same kind of process. So if I've got this, what I'm going to do is try to get rid of the fractions in this first equation. So I can remember that this here is a 4 over 1. So my denominators here are 3, 2, and 1. So to get rid of these fractions, I multiply by a common denominator. Well, my common denominator here could be 6, right? So when I multiply everything by 6, that is going to give me, well, 6 times 2/3 x minus 6 times 1/2 y equals 6 times 4. So 6 times 2/3 x, remember that's 6 over 1 times 2 over 3, which can be written as 6 times 2 over 1 times 3, which is 4, all right? Excuse me. Same process here now. 6 times 1/2, so that could be written as 6 over 1 times 1 over 2, which is 6 over 2, which is 3. And 6 times 4, of course, is 24. Okay, so that's my new equation. So it's really the same equation as this one I started with, but it's much nicer to look at. Now I'm going to take the second equation, my common denominator, 2, 4, and 2. Well, all of these denominators go into 4, so I could multiply this equation by 4. So I take everything, multiply it by 4, following the same process. That gives me this here. So now I've got these two equations right here. They are equivalent to what I started with, but they're much nicer to look at. So now what I can do is just take these two and perform the elimination process on that. So here are my two equations. I'm going to use elimination to find my solution. So first, it doesn't matter which one I choose to eliminate first. I'm going to eliminate y here. So to eliminate y, what I want is for these coefficients to be the same. Well, this here is a 1, So I could say that 1 and 3 both go into 3, but I also need to take note that the signs are the opposite. So there is another way to handle this, but usually what I recommend to keep things simple is if my signs are opposite, when I go to multiply by a number to get the same coefficient, I would multiply by a negative. So for example, 1 and 3 have a common multiple of 3. So since this is a negative 3, what I could do is multiply this equation. Instead of just by 3, I could multiply it by negative 3. So what that'll give me is that negative 3 times 2x plus y equals 10. So this gives me negative 3 times 2x, which is a negative 6x, negative 3 times y, which is a negative 3y, which is the same term that's up here now, same coefficient on the y term, okay, and negative 30. Now you notice that these both have negative 3y, so I don't really need to do anything with the first equation. I can leave it as is and just go ahead and subtract these now. So 4 subtract negative 6, again that's the same as 4 plus 6, gives me 10x. Negative 3 subtract negative 3 is the same as 3 plus 3, which is 0. And 24 subtract negative 30 is the same as 24 plus 30, which is 54. Now, of course, to solve for x, I would have to divide both sides by 10, which gives me 54 over 10, which can reduce to 27 over 5. Okay, so now let's do the same kind of deal, but eliminate x this time. So to eliminate x, I take note of what I have here. I've got coefficients of 4 and 2. I note that 2 goes into 4, so all I really need to do is take the second equation and multiply it by 2 to have a 4x term in both equations. So I'll multiply equation 2 by 2. Okay? That's going to give me this here. All right, so 2 times 2x, 2 times y, 2 times 10. 2 times 2x is 4x, 2 times y is 2y, 2 times 10 is 20. So now I've got these two equations, taking note that this is just the first one that I started with, and this is the second one transformed. So now what I've got are these two equations. They both have the same x coefficient, so I can subtract them. 4x minus 4x is 0. Negative 3y minus 2y is negative 5y. And then 24 minus 20 is 4. Of course, now to solve for y, I would have to divide both sides by negative 5, giving me y equals negative 4 over 5. So now I know that x is equal to 27 over 5, and y is equal to negative 4 over 5.